In this lesson, we're going to wrap up our introduction to Python programming with something a little bit more fluffy. A hot topic on the internet is always coding style. But what do I mean by coding style? Coding style is whether you use capital or lowercase letters, whether you use tabs or spaces, where you put your curly brackets, and so on. It's how you arrange your code and what sort of syntax you use. Now, the thing about programming style is that it's the classic bike shedding problem, right? Everybody has an opinion on what color the bike shed should be, and so everyone gets in a heated and lengthy argument about it. In the same way, people also have very strong feelings on how code should be formatted. Now, the irony is that the standards vary hugely between programming languages. So mainstream Python programming style is a little different from the mainstream Java programming style, which again is different from C++ or Swift. So the question is, how do we find out what good Python programming style is or should be, and what are the guidelines that we should follow, or what are the guidelines that people tend to follow? Well, lucky for us, there are so-called style guides out there on the internet. And the most popular style guide, I think, these days for Python is the official one from the Python Software Foundation. And it looks like this. It's called PEP 8, the style guide for Python code. And if you ask me, this makes excellent bedtime reading. Yeah, it's pretty long. It's very comprehensive. And it's also not something that needs to be followed religiously. It's a suggestion for writing readable Python code, right? Readable for humans. The computers don't really care. Now, the thing I'll say is that this isn't the only style guide out there. In fact, many companies have their own style guides too that, might be slightly different from the ones of the Python Foundation, for example. So here's the style guide from the engineers at Google, the Python style guide, to be specific. Now, I was actually looking through this and trying to spot a difference with the Foundation's style guide. And the thing I noticed is that these style guides are actually very, very similar. And there are maybe like some differences. Python Software Foundation says line length should be 80 characters. Google says it should be, 79. But most of the suggestions are actually really, really similar. So one of the differences I actually found seems to be more philosophical than anything else, right? So at the end, Google says, in their parting words, be consistent, right? This is the formatting they use, all caps, right? In contrast, the PEP 8 style guide from the Python Foundation says, a foolish consistency is the hobgoblin of little minds. So what they're saying here is that you can be a bit more flexible in your coding style if you need to be. Now, as I said before, in the end, none of these style guides are hard and fast rules. They're more about aesthetics and readability of the code. So you yourself, you can make a choice, right? You can choose one of these style guides and just stick to it. That's really all there is to it. That said, let's have a look that we've written so far in the lessons and see how it stacks up against the style guide from the Python Software Foundation. I'm not going to ask you to read through all of PEP 8 and play Spot the Difference, but truth be told, we've actually violated some of the style recommendations of PEP 8. So what I want to do in this video is kind of give an introduction to familiarize ourselves with what is considered good practice, and afterwards we can return to our Python code and make changes if necessary. One thing that we've already alluded to in the previous lessons is the indentation, so the layout of our code. And we recommended that we use 4 spaces for each indentation level. If we look back at our Jupyter Notebook, we can see that this formatting has already been taken care of for us, right? So we can see that this print statement, open door, is 1, 2, 3, 4 spaces indented. So in many ways, the editor that we're using, Jupyter Notebook or other text editors, modern text editors, not Notepad, actually shoulder some of this code formatting burden for us. Another thing that I want to point out is naming conventions. So I'm going to dwell on this a little bit because it's very, very handy for reading and interpreting the code that other people have written. So naming conventions are handy for being able to read Python code and know a little bit more about what it is that you're looking at just from how it's typed. So let's start with variables. Typically, you'll see variables written as single letters, especially if you're doing math or physics or machine learning, right? So lowercase y, capital X, these are variable names that you'll see very, very often. Now, short variable names like this are good when there's like an accepted convention in place. So, for example, with scikit-learn, you'll often see the variable name for the training data as capital X, and you'll see the target values as lowercase y. And this is a convention that they adopt and try to be consistent with across like their whole code base. But there is also a big advantage from not using single letters for variable names. Because if you have a descriptive variable name, right, as opposed to a single letter, you can help make your code a lot more readable. For a nice, long, descriptive variable name, you'll want to write it in all lowercase, and you want to separate, if there's multiple words, you want to separate the words with an underscore. So lightning underscore McQueen was an example of this kind of formatting. And if you really want to use single letter variable names, then please do not use lowercase l or uppercase I or uppercase O as your variable name. It's really hard to tell these apart with smaller fonts, right? If you're looking at a screen. So yeah, single letter variable names, maybe just exclude these ones for readability. Now, module and package names, they actually tend to follow the same naming conventions as variables, really, right? They're written in lowercase, and the longer names have the words separated, again, with an underscore. And again, for functions and methods, we typically use lowercase words separated by underscores as well. If the function in question has parameters, then the parameters tend to follow the same naming conventions as with variables. So with this in mind, we can actually quickly spot the coding style in our Python intro notebook where we've run afoul of these guidelines. For example, at the very top of our Python intro notebook, we had some variables called my age, restaurant bill, and service charge. And these are written in camel case. So camel case means starting with a lowercase letter and then capitalizing each word. And this is quite a popular style in programming languages like Java, but you see it much less in Python. Cool, so that pretty much covers our introduction to Python programming. We'll be diving deeper into Python programming techniques in the subsequent lessons, because programming is actually strongly linked to both data science and machine learning. And the reason is that programming goes well beyond how to call functions from scikit-learn. Knowing programming develops your mindset as an engineer. And to succeed in this course, and with machine learning more generally, having an engineering mindset is key. As part of this course and in the workplace, you're going to be putting a lot of different skills together from different fields. And those include mathematics, statistics, design, and of course, programming. And the reason is that outside of academia, you're going to be in a position where you're going to be trying to solve a real-life business problem. And figuring out how to solve this problem will test your engineering mindset. You know, a common misconception these days is that to solve problems, you need to use the most sophisticated model possible, or, artificial intelligence. Everybody's talking about AI, right? Artificial intelligence. However, in reality, AI is not the only thing that matters, and AI doesn't solve all problems. Now, depending on your specific problem that you're faced with, AI might not even add all that much value, especially considering the high cost and the high amount of data required to build an AI system. So, with your engineering mindset, as an engineer, you're going to be thinking about how to solve your problem in an efficient way. So maybe a simple model will do for your purposes. And this is why this course will teach you a variety of tools. And that way, you can use the right tool for the job. After all, if all you've got is a hammer, then everything starts to look like a nail. And coming back to programming, and programming in Python specifically, Python is actually a really, really nice language to start learning to program, in contrast to other languages like C or C++, because Python actually takes care a lot of the error-prone grunt work that goes on behind the scenes for you. And I don't think this is a bad thing, because unlike with C or C++, with Python, you don't have to do chores like laying out the memory structure, managing the memory allocation, or implementing access routines. Now, don't get me wrong, I think there is a time and place for all those things, and becoming familiar with how computer hardware actually works will definitely help down the line. But I don't think it's useful to get confronted with this right away, especially if you've got so many other things to worry about. Which brings me to our next topic. Where are we going next? The next couple of lessons and sections will introduce you to the core of machine learning, namely loss functions and a technique called gradient descent. This is where the actual learning takes place, and we're going to take a look at how this works under the hood for regression techniques. Also, we're going to be looking more closely at regressions that use more than one explanatory variable. In other words, we're going to spice up our regression model. For example, if you were trying to predict a house price, then you probably have to look at a number of different factors, like the number of bedrooms, the location, the total area of the flat or the house, the proximity to amenities like a park or a good school. There's a number of factors that contribute to a price of a house. And the technique that will tease out the individual contribution of each of these factors is called multivariable regression. And on that bombshell, it's time for me to get some more coffee, and then I'll see you in the next lesson. Take care.